Okay guys, so we have a little bit of information from the problem that could be useful. For one, we know the mass of the couch. So the mass was equal to 200 kilograms. And we're pushing it. It has a coefficient of kinetic friction of 0.6. And they're saying that the couch is moving at a constant velocity. That's pretty important. And they're asking for how much force do you need to apply to keep it moving at that constant velocity, to have it moving at that constant velocity. So we have our force of gravity pulling down, our normal force, equal and opposite, pushing back up. We have our force of friction, which is fighting that motion. And we have our force applied. So we start out by writing our two equations. One of them is always the same. Okay, the other one we're going to make using our free body diagram. So normal and gravity are going to kind of cancel each other out. So we're left with force applied minus the force of friction. Let's take stock of what we already know. We know the mass, and we are looking for the force applied, and we don't know friction. Maybe we can find it though. Okay. At this moment is when it really helps to stop and read the problem very carefully. So they said constant velocity, constant velocity. That means that there actually is no acceleration. It's a little bit different problem. So what that means is that my force of friction is actually equal and opposite to my force applied. So all my forces are kind of canceling out. That's what happened when we have a constant velocity. Just like when you were doing the mu of your shoe lab and you had to pull at a gentle constant velocity, that's why we did that. So weirdly, when we look at this equation, our net force is equal to mass times acceleration. So mass times 0 is 0 newtons. And you're like, whoa, that's weird. So that is also our net force here. So F net is equal to 0, which is equal to the force applied minus the force of friction. We're looking for the force applied. So the last thing we need to find is the force of friction. So how do you find the force of friction? Well, remember that the equation for force of friction is mu times the normal force. So let's see which of those we have. Well, we definitely have the mu. It was given to us. Okay. And we kind of have the normal force. And by that I mean, okay, we look, normal force is equal to the force of gravity. Okay, so if we could find the force of gravity, we can find the normal force. Well, remember that force of gravity, if you ever know the mass, you know the force of gravity. And the way they're related is mass times gravity. So force of gravity is equal to 200, and G is 9.8. So our force of gravity is 1960 newtons. So now that we know our force of gravity, and we know our force of gravity is equal and opposite to our normal force, we can apply that back to this equation. So force of friction is equal to mu times the normal force. Force of friction is therefore equal to, mu is given to us, so 0.6. The normal force is same as gravity, so 1960. So our force of friction is 1176 newtons. Okay, so now let's go back. We are looking, again, I always circle what I'm ultimately looking for. It helps me keep track of it. We're looking for the force applied. We found 0 equals force applied, and now we know the force of friction. So 0 equals force applied minus 1176. So force applied will be equal to 1176 newtons. The other way you could have done it a little faster than doing that is just go find that force of friction. So you could have just done this part, okay? And then known that the force of friction would have to be equal to your applied force in order to get that constant velocity. They have to be equal and balanced. So that's probably the faster way to do it.